So first thing, you guys don't have to write this down because we've already written this down our first week. But it's the symbol for absolute value. Does anybody remember what the symbol looks like when you write absolute value? Yeah?
Is it two straight lines?
Yeah, it's like those two straight lines, right? Like those two bars. So we're going to see a lot of these today. Okay, the two vertical bars. Again, you don't have to write the symbol down unless you don't remember it. But that's the symbol for absolute value. So if I wanted to write down absolute value of 4, can somebody tell me what I would write down? Yeah? Yeah, 4. And then I would put the 2 bars around it just like that. Okay, that means absolute value of 4. And does anybody remember, maybe not, I don't know, what absolute value measures? Yeah? Exactly, perfect. It measures the distance that a number is from 0. So on your guided notes at the top, the first thing says absolute value measures, and you want to write down the distance a number is from 0. Or you could even just shorten it to say distance from 0. So if we have an equation that has those bars in it, okay, like this. Any equation that has bars in it is called an absolute value equation. Okay, that part, you don't have to write this part down. I'm just telling you, if an equation has bars in it like that, it's called an absolute value equation. Okay, so you don't have to write that down. All right, so how do we solve an absolute value equation? This you want to write down. So there's one thing we have to make sure of first. If you had a problem like this, that's good. That's a problem that's ready to be solved. If you had something like this, that's not good. That's not ready to be solved. So this one is ready to be solved. That one isn't. The difference between the two is in the top one, all you have on the left-hand side is an absolute value. In the bottom one, you have an absolute value, but you also have something outside it. We don't want that. So when we're trying to solve an absolute value equation, we have to, and this is the first step on your guided notes, ensure that the absolute value is by itself with nothing else next to it. You can have a bunch of stuff inside the absolute value. That's fine. But you don't want to have something outside it. Like in this one. That's no good. You don't want that 3 there. So ensure that the absolute value is by itself on one side of the equal sign. It doesn't matter if it's on the left or it's on the right, but it has to be by itself. Then right below the line that says ensure, you have something that says if, and then it's followed by 3 dots. If there is a number attached to the absolute value bars, we want to divide both sides by that number. And I'll show you guys an example. And when I say attached, I mean right next to it. It's actually, I think it's already printed on your guided notes what it looks like. So if there is a number attached to the absolute value, we need to get rid of that number before we can do anything else. Divide both sides by that number. Okay, do you guys already have that example printed on your notes? Okay. So that's an example of something that we don't want. The absolute value is not by itself. It has something next to it. We have a 3 attached. So using the step above, can somebody tell me what I would have to do on each side to get rid of that 3 that's attached to the absolute value? Yeah?
Divide both sides by 3.
Yes. I would divide both sides by 3. What that does is it cancels this 3 out. Because right before I cancel there, basically right here, you have 3 times the absolute value of something. I don't care what's in that box. Okay, so for now, if you want to pretend, there's something in that box, it doesn't even matter what's in it. All I know is I have a 3 attached to it, and I don't want the 3 attached. So I'm going to divide each side by 3. That's gone. Divide that by 3. So on the right side, what's 6 divided by 3? 2. And on the left side, all I have now is my absolute value. Now I need to know what was inside it. It was, move those out of the way, 2x plus 5. Now that's an absolute value that is ready to solve, because the absolute value is by itself on the left. So that's one way that it might not be by itself. You might have a number attached to it. If, this is the second thing. Let's say that you not only had a number that was attached to it, but then you also had something that was added or subtracted from it. So not only do you have a number attached, like maybe something like this, let's say 3, and then you had something in absolute value, doesn't matter what's in the absolute value, but now you have a number attached, and let's say you put a plus 6 here. This has 2 problems. The first one is you have a plus 6, and the second one is you have a number attached to it. We have to fix both of those. And here's the order that you fix them in. It says, do the opposite operation on both sides of the equal sign. So if I look at this, I see a plus 6. The opposite operation of a plus 6 would be a minus 6. That would be my first step. We get rid of the number that's added or subtracted by doing the opposite. Then the next step is the same as the step I just gave you. Get rid of the number that's attached right in front. And how do we get rid of the number that's attached? Divide. All right, so we'll try an example of this where it has 2 things we need to fix before we can solve. Do you guys already have that example printed on your notes? Okay. So with this one, two things I don't like. I don't like the 6 that's attached, and I don't like this minus 14. All I want on the left-hand side are the bars. So I have to get rid of both of them. Do this one first, and then we're going to do this one second. To get rid of the negative 14, it says do the opposite operation. What's the opposite of a negative 14? Yep, positive 14. Don't do anything else in this step. Leave the 6. Leave the a minus 7. All we're going to do is plus 14, plus 14. Negative 14 plus 14. What happens? Yeah. They cancel out. You added 14 to cancel it out and put it on the other side. 10 plus 14 gives me 24. All right. Now, is the absolute value by itself? Not yet. Now, there's a 6 left there. How do we get rid of 6 times something? We have to do the opposite of times. Yeah? And what would you divide by? 6. Perfect. Divide by 6. Divide by 6. That gets rid of the 6's. Now, the absolute value is by itself, and we're ready to solve it. This would be the hardest kind of problem you could have, because you had to fix a couple things before we could even start. So the absolute value, a minus 7, is by itself. And 24 divided by 6 is what? Okay, so any question on that idea first? That's important, to get the absolute value by itself.
Do you want us to solve it all the way?
So, yes. So once we get the absolute value by itself, now we actually have to solve for a. Like, what is a? 6, 2, 5, negative 8? Or what's a? To solve for a, we have to get rid of these bars. We've never seen those bars in an equation before. So this is how you get rid of them. So under 2, where it says eliminate, you want to copy the part after eliminate. So eliminate the absolute value bars by splitting the original problem into 2 problems. But make sure you've done step 1 first. If step 1 was already done for you, well, great, then you don't have to do it. But if it's not, then you have to do step 1 first. So when we split this into 2 problems, what we're going to be doing is solving 2 different equations. And we're going to usually get 2 different answers. So these kind of equations are a little bit different because they have more than one answer. They have 2. So what we're usually going to do when we split it is I'm going to draw 2 arrows, kind of like I'm showing you in that diagram. And I'm going to put one over here, and I'm going to put another one over here. But we have to know how to split it. These are the 2 things you want to write down that I just put boxes around to how we split it. First of all, when we split it up, we take the bars away. The bars are gone. So the vertical bars, get rid of them. One of the equations we're going to write down is exactly the same as the original problem. You literally take away the bars. So let me show you an example of that, and then I'll show you what the other side is. If I was going to solve this one, okay, and I'm going to put it back up. You're going to have time to copy this down. I would start by going like that. The first one, and again, you can just watch this, because I'm going to give you guys time to write this down in a minute. The first one that I would do is this. Take the original problem and just get rid of the bars. So write x plus 1, get rid of the bars, equals 3. That's the first problem we split it into. But we need a second one. The second one is right here. For the second one, we're still going to write it with no bars, okay, because that's the whole point of splitting it. We're getting rid of the bars, but we change the number on the other side to a negative. We change the number on the other side to be a negative. So let me show you that, and then I'll give you the last step right here. So change the number on the other side to a negative. All right, so if I was doing this one, copy it down without the bars, but change the number on the other side. You're basically making it its opposite. So if this was a positive, I make it a negative. If it already was a negative, then I would make it a positive. All right, but it's most of the time, it's just going to be a positive. So you're going to make it negative. That's how you split the two up. Same problem, take away the bars. Same problem, but make the number on the other side negative. Once you split it into two problems, now the last thing to do is solve them. So now you have two equations to solve. Most of the time, they're not going to have distributive property. They're not going to have combined like terms. So even though you have two problems you need to solve, they're going to be easier problems than what you did in last night's homework. They're not going to have the distributive property. So the steps that we use to solve the equations generally end up being the same. Even though you have two of them, it's the same steps in both. So it actually isn't that bad. And I'll show you what I mean by that. But you end up doing the same exact steps to solve both of them. Because they're almost the same equation. They're almost the same thing. We're almost always going to have two answers when we solve them. So you can put that on the second bulleted line. And this thing that I wrote in words here, I think that's already printed on your guided notes. If you look right above the number 3, does it say that the answers are connected with the word and? Yeah. So you don't have to write that down. That's already printed on your notes. You do have to write those two things. Yes? Yep. So those are the steps for today. So now we're going to practice some examples. I think that'll, if the steps seem a little confusing, I think an example will help a little bit. Okay. Does everyone have those two things under solve? Okay. And again, you don't have to write this. because it's already printed on your paper for you. Okay, so we kind of already started this one together. This is on the back of your guided notes, where it says example 1A. It's the top left box. If you want to go outside the box, you can. I just put boxes to try to organize each problem for you. So, step 1. Ensure that the absolute value expression is by itself. Is this absolute value by itself on the left-hand side? Yeah. It doesn't have like a times 5 in front of it, or it doesn't have a plus 6 on. It doesn't have anything like that. So the absolute value is by itself. So once we know that the absolute value is by itself, we can split it. So we go right to step 2. Split it into 2 problems. Both of the problems don't have the bars. The first problem is exactly the same as the original, except you don't put the bars. So now, if you didn't copy the example down, now you want to write that down. The second one is the same as the original, except we don't have the bars, and we make the number on the other side a negative. And now, we solve each problem. But as I told you before, these equations are going to be pretty simple. They won't have like terms, they won't have distributive property. So does anybody see what the one step is to get x by itself? And it's going to be exactly the same in this one and this one. That's why I said you use the same steps. Michael?
Subtract one from both sides.
Yep. Subtract 1 from both sides. And you're going to do it here as well. It's exactly the same step on both of them. And Anaya, what's a plus 1 and a minus 1?
Nothing.
Cancels. It's gone. X equals, and Joe, what do I get in this case? X equals how much?
2.
2. Very good. That's my first answer. Second answer, plus 1 minus 1 is gone. And Abby, I get x equals, that would be negative 3 plus 1. This is negative 3 minus 1. Think about if you're at negative 3 and you take 1 away from it, you're going to move 1 more unit to the left on a number line. Negative 4. Yep. So x is negative 4. Now, the last thing it said is to connect the 2 answers with a certain word. What word did it say to put? Right there, yeah? And. And means it could be either, it's both of them. X equals 2 and negative 4. Both of those numbers are answers to your problem. Any questions on that? That's how you solve an absolute value equation. So we'll try a couple. I think I had 3 or 4 of them. And then that'll be it. Yeah. The number line? Oh, did it say? Oh, it did say graph. Okay, so I should probably scroll down. Yep, here's the number line. So to graph your answer, all you have to do is put a dot on the number. So you guys don't have the number line filled in, so we need to fill it in. Let's do negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. When they ask you to graph your answer, this is all you have to do. Put a dot on 2 and put a dot on negative 4. What you're doing is you're coloring in where the answers are. And that's it. So on edge elastic on the test. If I ask you to graph your answer, most likely I'll give you something where you can click a dot and put it on the number line. And if you put it in the wrong spot, you'll be able to click on the dot and move it wherever you want to put it. That's how you do that on the computer. Okay, any question on that? Good, thank you for reminding me about that. All right, let's try this one. So I'm going to give you guys a second to try it. I'm just going to ask one question first. Is the absolute value already by itself? Yep. Yes, it is. So you are ready to split this into two problems right away. Okay, so take a couple minutes, see if you can solve that, and I'll walk around and help you out if you get stuck. Start to take a look at it. We already said that the absolute value is by itself, so we're ready to split it. You don't have to solve it, but can anybody tell me what the first equation would be that you're going to split this problem into? What's going to be the one that I put on the left? Yep.
2x plus 4 is 8.
Yes, exactly. 2x plus 4 equals 8. Now, we need to solve it, but let's write the other one first. Kate? So 2x plus 4 equals negative 8. So we split it into two problems. That's perfect. Does anybody have any questions on how you get those two equations? All right, now we just solve it. Let's start with the one on the left. Dorian, what's my first step to solve this?
Subtract 4 on both sides.
Yep, subtract 4 on both sides. That's gone. And that gives me 2x equals how much? 4. Okay. Now, I have one more step to get x by itself. Sean, what would be my last step?
By 2x.
Divide that by what?
2.
2. And anything else? And divide 4 by 2. 2 divided by 2 is gone. And that gives me x equals how much? 2. Now, before I graph that, I want to solve for my other answer. And I'll do the graphing at the end. Okay, so I know x equals 2. And the steps to solve this one are exactly the same. Minus 4 from both sides. Plus 4 and minus 4 is gone. That's going to leave you with 2x, just like we had before. And negative 8 minus 4 is, yeah, negative 12. Good. Now, the last step is the same as the last step here. Divide both sides by 2. And negative 12 divided by 2 gives me negative 6. Very good. So those are my two answers. Now, I'm going to look at my number line and see if I have enough room. Negative 6, 5, 4, 3, 2, 1, 0, 1, 2. Yes, I have enough room to do this. So I'm going to start here. If I didn't have enough room, then what I probably would have done is I would have gone by 2s. Like 0, 2, 4, 6, like that. And how do we graph our answers? What do we have to do? Yeah.
Put a dot above each of those.
Yeah, just put a dot. Make sure if you get this far that you don't mess up and accidentally put the dot on like negative 2. It's positive 2. So dot on positive 2 and on negative 6. Any questions on that? So we've got one more of this type. Let's do this one together, and then we'll do one of the type that you need to fix before you can start it. Okay. So example 1c. Is the absolute value already by itself? Yes, there's stuff inside the absolute value. That's fine. But the absolute value is by itself. which means we're ready to split. Brady, can you give me one of the equations that this splits into?
3x equals 21.
Good. 3x equals 21. And we should write down the word and, so we don't forget that. I might not have done that on the last problem, but we should put the word and. So 3x equals 21. And what's my second equation? Yep. 3x equals negative 21. And now the step to solve it is the same in both. What's the only step I have to do to get x by itself? Yep. Yep. Divide everything by 3. That's gone. And that's gone. If you get something you can reduce, you should reduce that as much as you can. So what is 21 divided by 3? Yep. 7. That's one answer. And can someone tell me my other answer? X equals -7. Good. -7. And that's it. So on the test, it would be set up so you have 2 boxes. You click in one box, you type your first answer. You click in the other box, you type your second answer. It would not matter what answer you put in what box, as long as you put 7 in one box and -7 in the other. Okay, any question on that? All right, so the last 2, those are the ones that are a little bit harder because the absolute value is not by itself. So we'll do this one together, and then I'll have you guys try one on your own, where you have to do this step first. Okay, so example 2a. I already said to you the absolute value is not by itself. How come? What's there that I don't want there? Yep.
The 2's in front of the absolute value.
Yes, I don't want that 2 in front of the absolute value. Before I split it, I need to get rid of it. So how do I get rid of this 2 times the absolute value? Yep.
Divide 2 by 2 and then 4 divided by 2.
Yep. We're going to divide both sides by 2. Don't do anything to what's inside those bars. Leave what's inside the bars alone. All you're doing is that. When you divide each side by 2, the 2 cancels out. What's on the left side once I cancel out 2? Yeah?
3y plus 5.
Anything else? So yeah, equals 2. Still something else we have on the left-hand side that we haven't gotten rid of yet. What do we have above that we didn't copy down? Yeah, the bars. We didn't get rid of those yet. Now we're ready to get rid of them. But any question on why we had to divide by 2 first? All right, so let's split it up. How about Anaya? Can you tell me my first equation that'll split up into?
3y plus 5 equals 2.
Good. 3y plus 5 equals 2. And Brady, my second equation?
3y plus 5 equals -2.
Yep. And now, there's 2 problems to solve, but they're not as bad as last night. There's no distributive property. There's no combined like terms. So, Emily, how would I get y by itself? Good. Subtract 5 from both sides. That leaves me with 3y equals, what's 2 minus 5? Good. Negative 3. Divide each side. I need to move that down a little bit. Divide each side by 3. And one of our answers is y equals negative 1. And now do the same steps to solve the other equation. Okay. Minus the 5 on both sides. That's gone. What's negative 2 minus 5? Yeah?
Negative 7.
Negative 7. Now, this one's not going to come out nice. When we divide by 3, we're going to use our calculator and we're just going to round it off. Let's do 7 divided by 3. That's supposed to be a negative. So that's negative 2.3. So when we graph it, just do your best to estimate where that is. We'll call this 0, negative 1, and negative 2. Well, I know where negative 1 is. Where's negative 2.3? Yep.
We don't have any graphs on it.
Oh, we don't have the graph for 2a? Okay, that's okay then. Negative 2.3 would be a little bit past negative 2. But yeah, you did have the graph on that, so don't worry about that. But any questions on how to solve it? All right, so last one. So I'll ask you guys a question, but then I'll kind of let you go from there. I'm going to fix this a little bit too. I want to make this number, just make it a 12. So just put a 1 in front of the 2. Is the absolute value by itself? No. So do what you need to get it by itself first. Then split it into 2 problems. So I'll give people a couple minutes to do that, and then we'll go over it, and then we'll be done. All right, so we said absolute value wasn't by itself. What did you guys do first to get it by itself? Natalie? Good. Subtract 5. And when you did that, what did you get for 12 minus 5? 7. Okay. Now the absolute value is by itself. How about Maya? Can you tell me my first equation?
X minus 1 equals 7.
Perfect. And my second equation? Yep. X minus 1 equals negative 7. And what do we do on both sides to get x by itself? We're going to do it twice. Yep.
Add 1.
Add 1 on both sides. So my first answer is 8. And what is my second answer? Negative 7 plus 1. Great.
Negative 6.
Good. Negative 6. And there was no graph on that one, so you didn't have to graph. All right. Nice job. So homework tonight is worksheet 1.4 online. The problems you covered, get them off Schoology. If you had any problems and need extra help, I am staying after school tomorrow, so that's my late help day. And remember, we have our second test on Friday.